Hi guys, in this video I'd like to show you a strategy that you can use for solving simple trigonometric equations that involves a negative number. For our first example, we're going to solve the equation sine theta is equal to negative 0.5 with theta being between 0 degrees and 360 degrees. We're going to break this up into 3 steps. The first step is to establish which quadrant theta is in. Since sine theta is negative, this means that theta is either in Q3 or Q4. Our second step is to begin solving the equation. First, we're going to ignore the negative sign in the equation and we're going to solve for the related acute angle. So we say, let theta be the related acute angle of sine theta is equal to 0.5. Notice how the negative sign in front of the 0.5 has been omitted. Then we're going to solve for sine theta is equal to 0.5. So theta is equal to inverse sine of 0.5, which is equal to 30 degrees. So this means that the related acute angle theta is equal to 30 degrees. And in our last step, step 3, we're going to now begin writing the solutions. The first thing though is to observe the domain. For this question, our domain is theta being between 0 and 360 degrees. Then we're going to mark the angles on the quadrant diagram. So we've got the related acute angle of 30 degrees. We're in Q3 or Q4. So on our quadrant diagram, our first solution is going to correspond to this ray in Q3 with the related acute angle of 30. Our second solution is going to correspond to this ray in Q4, again with the related acute angle of 30 degrees. Now we're going to write down all the solutions. Our first solution in Q3 is going to be 180 degrees plus 30 degrees, which is equal to 210 degrees. And our second solution in Q4 is going to be 360 degrees minus 30 degrees, which is equal to 330 degrees. So therefore, for this question, the solution is theta is equal to 210 degrees or 330 degrees. Our last question, we're going to solve for tan theta is equal to negative 2. This time theta is between negative 180 degrees and 180 degrees. We're going to again break it up into 3 steps. First, we're going to establish which quadrant theta is in. Since tan theta is negative, this means that theta is either in Q2 or Q4. Then we're going to begin solving the equation. So in step 2, we first ignore the negative sign in the equation and we're going to solve for the related acute angle. So we say, let theta be the related acute angle of tan theta is equal to 2. So notice how the negative sign in front of the 2 has disappeared. So we're going to solve for tan theta is equal to 2. Theta is equal to inverse tan of 2. And with the calculator, this gives us 63 degrees to the nearest degree. So therefore, our related acute angle, theta, is equal to 63 degrees. So our last step, we're going to begin writing the solutions. First, we're going to observe the domain. Now for this question, the domain is between negative 180 degrees and 180 degrees. So we're going to mark the solutions on the quadrant diagram. So we're given that the related acute angle is 63. We're in Q2 and Q4. So on our quadrant diagram, our first solution is going to correspond to this ray in Q2. And our second solution is going to correspond to this ray in Q4, both of which has got the same related acute angle of 63. Now we're going to write down all the solutions. Our first solution is given by 180 degrees minus 63 degrees, which is 117 degrees. Now, since the domain goes from negative 180 to 180, our second solution, we're going to be traversing in the negative direction, which is clockwise. So we're going to traverse this direction, and this ray corresponds to negative 63 degrees. So our second solution in Q4 is negative 63. So for this question, our solutions are theta is equal to 117 degrees or negative 63 degrees. Thanks everyone for watching the video. I hope you guys found that useful. For more videos on this topic or other topics, please have a look at our channel. And if you haven't already, don't forget to subscribe. We release videos weekly and we hope to see you all in the next one. Bye for now.